Welcome back to another video. In this video, we are going to be talking about the fundamental counting principle. Okay, and so just a basic example of when you use the fundamental counting principle. Say you have 3 shirts and 2 pair of pants, 3 work shirts and 2 pair of nice slacks. How many different ways can you put outfits together? So how many different outfits can you create from your 3 nice work shirts and your 2 nice pair of slacks? You could put 6 outfits total. So you'll have enough for 1 week full of work, Monday through Friday, and 1 day of the next week. Okay. How did I get that number? I did the 3 shirts times the 2 pants. 3 times 2 is 6. That's essentially what the fundamental counting principle is. And so for the formal definition of the fundamental counting principle, it is, well, for 2 options, so like I did shirt and pants, because you can have more than 2 options, but for 2 options, if you can choose 1 item from a group of M items and a second item from a group of N items, then the total number of 2 item choices is M times N. So that's basically what I just did. I multiplied the 3 and the 2 to get how many outfits I could create. How many 2 item outfits I could create with a shirt and a pair of pants. All right. So now let's look at some examples. Let's look at some formal examples of how we will use the fundamental counting principle. So example 1, the Broken Yolk Cafe offers 6 appetizers and 14 main courses. All right. And how many ways can a person order a 2-course meal that includes appetizer and a main course? So you have 6 appetizers and 14 main courses. So the way you would calculate how many 2 item course menus you can have, or full course dinner you can have, or meal, however you say it, 2-course meal you can have, you will multiply the 6 and the 14, and 6 times 14, you get a total of 84. So there are 84 different combinations of ways you can order an appetizer and a full course meal together. All right, so that's example 1. So now that's if you have 2 options. So with that one, it was an appetizer and a meal, right? But you can have more than one option. So here's the fundamental counting principle in general. So here's the general definition. The number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So regardless of how many options you have, you'll just always take all those options and multiply them together. So let's look at an example of how you would do that. So in example 2, suppose that next semester you are planning to take math, English, and humanities. All right, based on time blocks and highly recommended professors, there are 8 sections of math available, 5 of English and 4 of humanities that fit what you need, that you find suitable. So assuming no scheduling conflicts, how many different 3-course schedules are possible? So you have math, English, and humanities. So you have to look at how many math options, how many English options, and how many humanities options. So there are 5 math options. There are 8 math options. There are 5 English options, and there are 4 humanities options. So to figure out how many possible 3-course combinations you can take, how many 3-course schedules are possible, you will multiply those all together. So 8 times 5 is 40, and 40 times 4 is 160. So that means you can create 160 possible ways you could take those 3 courses based on the options that are available for you. So here's another example. Suppose you are taking a multiple choice test that has 10 questions, and each of the questions have 4 answer choices with 1 correct answer per question. So your typical test, one of the answers is right, there are 4 options. If you select one of these 4 choices for each question and leave nothing blank, and how many ways can you answer the question? So what are the number of different ways you can answer those 10 questions. So there are actually 10 choices here. You have 10 questions. So I'm just going to put a little dash to represent each question. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'll put another one here, 10. Alrighty. So each one of these dashes represent a question. And so I want to multiply the number of options I have for each of those questions. Well, there are 4 options for each question. So for each of these little blanks, I will put a 4, because I have 4 different options to answer, 4 different ways I can answer each of these questions. And so what I end up getting is 4 times itself 10 times, which is the same as saying 4 to the 10th power. And so then you can just plug 4 to the 10th power in your calculator and figure out what you get. Now, Remember, if you're using, depending on what you're using, if you're using a calculator, you'll have a little button like this. That means that's a caret key. That means raised to a power. So you will write 4 caret key 10. But if you're using like a phone calculator, you'll have a button that says x to the y. And so what you'll do is you'll hit the 4, you'll hit the x to the y button, and then you'll hit the 10, and it'll give you your answer. So that's how you'll plug that in your calculator, and you actually get a total of 1,048,576. So there's a million different ways you can answer those 10 questions. All right, a million to be exact, 1,048,576 ways you can answer those 10 multiple choice questions. And for my very last example, we want to talk about telephone numbers in the US. They begin with 3-digit area codes followed by 7-digit local numbers. All right, area codes and local telephone numbers cannot begin with the 0 or 1. So how many different telephone numbers are possible? So how phone numbers are made, you have 3 digits that represent the area code. Then you have your local number, which has 3 digits, a dash, and 4 digits afterwards. Okay, now each digit can be 0 through 9 except for the first one of the area code and the first one of the local number. So this one can be 0 and it can't be 1. It can be 2 through 9, and so this one can be 2 through 9. All of the other ones can be 0 through 9, so that could be any digit from 0 to 9. All of these can be. So I'm just writing these out to let you know what are the possible options for each of these digits. So all the other ones can be 0 through 9. So if you count 2 through 9, how many options is that? 2, 3, 4, 5, 6, 7, 8, 9. That's 8 options. So for the 2 through 9, that would be 8 options for those. Okay, and then for 0 through 9, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 options. So for 0 through 9, each of those you have 10 options. And so you end up multiplying all of these because this is how many options you have for each of those digits. So you end up having 8 times itself twice, so that's 8 to the second, and 10 times itself 1, 2, 3, 4, 5, 6, 7, 8 times 8. So times 10 to the 8th power, 10 times itself 8 times. So this is what you'll multiply. You'll multiply 8 to the second, which is 64, times 10 to the 8. And when you multiply 10 to the 8, you get 100 million. Yeah, because you get 8 zeros. I think, let's see. Yeah, 6, you get 8 zeros, which is 100 million. But when you multiply that by 64, you get 6,400,000,000. Or we say 6.4 billion. I think that's right. Let me make sure. Yes, that is correct. So 6.4 billion or 6,400,000,000. So that's how many possible telephone numbers there are using the system that we use in the United States. Okay, so this is how you will use the fundamental counting principle. These are a few examples of how you will use it. If you have any questions whatsoever, feel free to put them in the chat or send a personal message. I hope this made sense to you, and if this helped you at all, please hit the thumbs up button, and if you haven't already, go ahead and subscribe to the channel. Thanks again for tuning in, and I will see you in the next video.